Hi, my name is Alistair Chapman, and in this video I'm going to take a look at the Accsoon Cineview Master 4K. This device here is not an unboxing video. I've got some tests and things to show you. Now, I did do this video yesterday, but it turns out that for some networking reasons the audio quality was really rather poor. So hopefully today the audio is much better, and I'm going to go through this really nice wireless video transmission system again. So let's have a look at the product itself. The product itself comprises of a transmitter and receiver. Let's have a look at these from the overhead camera. We have a transmitter and a receiver, and they work on both SDI and HDMI. And they give you up to 4K at 60 frames per second wirelessly. Now, one of the big things about these is that they have very, very low latency. And I really wanted to test that, because if the latency is low enough, then these would be really well suited to focus pullers and people like that, and people that need that very rapid connection between the camera and the destination. So let's start by having a look at the devices in a bit more detail. So this is the transmitter, and if we look at the antenna layout, this is a tri-band device. So this transmits on 3 bands. The antennas at the top are for 2.5G and 5G bands, the same as most Wi-Fi uses, and then the side antennas there for 6 GHz. So we have that extra third band that will give us generally better reception, less dropout, less fallout than just something that works on the Wi-Fi bands. If we look at this side of the transmitter, you'll see that we have an SDI input here. It's a 3G HD SDI input, so the SDI really is only good for HD. And then we have an HDMI input, and the HDMI goes up to 4K 60 frames per second, an HDMI loop-through output, and then another output here on a USB-C port. And then these come with a couple of cables, a USB-C to USB-C cable and a USB-C to Lightning cable. And what these allow you to do is to connect the transmitter to an iPad or iPhone, so you can use the iPad or iPhone as a very low latency, very high quality monitor, and I'll go into that in a little bit. Coming back to the transmitter itself, if we come to this side of the unit, you'll see there is a little OLED display here. There's a power on and off button up here, and then an OLED display that tells us our current setup. It says it's currently set to tri-band, using all 3 bands. The group number is set to 6. Now, when you're pairing 2 of these, all you need to do is to set the same group number on the transmitter and the receiver, and they will pair. The receiver will find that transmitter very simply, very easily. And currently going into this is 1080p at 29.97 frames per second. Turning the wheel here takes me through the various setup option pages. There's not really a huge amount, but you do have the ability to change the bit rate and to switch between VBR and CBR, so constant bit rate or variable bit rate encoding. To be honest, I haven't really seen much of a difference between the two, and I've currently got this set to 9 megabits per second. The fan is set to standard, so there are fans in these units. This has a much more powerful processor in it than the other units, so I've also got somewhere here. So this is your classic Accsoon Cineview unit, and this is fan-free, no fans in this, but this is HD only. Whereas the new units, which have the fans in, they have a processor that supposedly can go up to 8K, but currently it's only used for 4K and up to 60 frames per second. That fan doesn't come on very often, and when it does come on, it's not particularly loud, and it's automatic, so the speed of it varies depending on the temperature of the unit. I haven't found it to be a problem. If we come back to the view of the unit again, we have our various country and region settings here. Currently this is set to EU, and because that's where I'm based. But an important thing to actually understand is you should use the correct country setting for your country. But the EU actually uses much lower power levels for the Wi-Fi frequencies than, say, the US does. So people in the US using it with the US settings will generally get much better range than we do here in the UK. Now, I did test the range to see how far I could go with these units, and outside, clear line of sight, easily 300 meters, no problem at all. Obviously, if you're in a more cluttered environment, if you're indoors, you can get reflections and things, and that will reduce the range of any wireless video transmitter. But I felt these did actually really well, and I think having that extra third band really helps with that. They don't really go through walls terribly well. The signal doesn't like going through brick walls and concrete walls, but that's the same with all of the video transmitters that use these frequency bands. It's just the nature of the frequencies that are used. It will go through wooden walls and plasterboard walls and things like that. But I found that even sort of like in a typical warehouse type environment or office environment, that I had no problems with dropout or breakup of the signal. Very, very reliable, provided there wasn't something solid between the transmitter and the receiver. So really sort of at least as good as anything else on the market, in my opinion, at least of this type of product. Now, the thing I really, though, wanted to look at with these was the latency. And actually, before I do that, let's just have a look at the receiver, because we've only looked at the transmitter so far. So let's have a look quickly at the receiver. So very similar looking unit, virtually the same OLED panel on the side here. Again, this one's set to group 6, so the two will sync. Same antenna arrangements, and we have an SDI out, which is HD, and then there is an HDMI out that can go up to 4K and 60 frames per second. Very simple device. On the back of both of them there is a slot for an NPF type battery, a really common low-cost Sony NPF batteries. Power-wise, they don't really seem to use that much power. I've been running them off this single V-mount battery here. It's a 100 watt-hour V-mount battery, and both of them have been running off that now for about 4 hours. So the power consumption is perfectly reasonable for them. It's a little bit more than the HD only units, again because we've got more processing power, but it's not really a problem. So coming back to this question of latency, because something that I often use a wireless link for is for feeding a monitor for follow focus, and if you can do that wirelessly, it makes it much easier. And what's important there is latency. If there's too much delay in the signal, when you turn the focus wheel on the follow focus, the lag in the system means it's very difficult to actually really hit that fine point with your focus. So to test the latency, what I did was I used this setup that I've got going on here. Let me just wake up my MacBook. So I created a video file on my MacBook at 60 frames per second, and that has time code. So let me just bring up the MacBook. So that has this time code number on it that increments for each frame. And then what I did was I fed that, I'm using a Blackmagic Ultra Studio, which has 2 SDI outputs, and one of those SDI outputs goes to the transmitter. The other SDI output is going direct to my Seemo monitor here, and then the output of the receiver is also going to the Seemo monitor, and I can see both images side by side, the direct image from the Ultra Studio and the transmitted image here. Now, just playing the file, it's very difficult to actually see any delay or latency. I can see that there might be a tiny bit, but I wanted to know exactly how much there was. So what I did was I then used another camera to video this screen, so I could then freeze frame it and look at those 60 frames per second frame numbers to compare them. So let's have a look at what that result was. So you just have to bear with me a second. So first of all, I need to turn off in DaVinci Resolve the data burn-in. So just turn the data burn-in off, so I'm not generating a new timecode number. So let's come back to the correct clip. Let me just close that window, just bear with me a second. Here we go. So on the left is the live feed, and on the right is the feed going through the transmitter, and this is 60 frames per second. And you can see that the number here, if we take this frame, we've got maybe 69/70 on the left. So the reason you're seeing 2 frames or a bit of one frame and another is because when I shot this with the camera's shutter wasn't exactly in sync with the monitor, and that's something very, very difficult to actually get. So you do see more than one frame number at a time. So I'm having to sort of extrapolate what we're seeing. And if we look at this frame, I've got maybe 69 and a 70 there, and over here I've got maybe 68. So if we're kind of seeing the tail end of 69 and 70 here and 68 here, it's about a 1.5 frame delay at 60 frames per second. If we go, let's pick another frame, let's try this one here. This seems to say this be a 2, maybe going on to a 3. We've got a 10 here, so it's about 2 frames. If we go, let's pick a frame, let's just randomly pick a frame, stop there. That seems to say 104/5, and this is saying 103, so about 1.5 frames. So my best estimate is that the delay at 60 frames per second is a touch over 1.5 frames, which is actually really good. That's a very minimal delay at 60 frames per second. And when you factor in things like your own reaction times and also the latency in your monitor, because most monitors have some latency as well, this one extra frame, 1 and a bit frames at 60 frames per second is actually a really good performance figure for a relatively low cost video transmitter. Now, if you're shooting at 24 frames per second, what that would actually mean is your delay would actually be a frame or possibly even less than a frame. And you have to consider things like the timing of when those frames are arriving in the monitor and when they're arriving in the receiver, and as I say, latency monitors anyway, latency in the monitor, as to how significant that really is. So that was at 4K, at HD, sorry, in 60 frames per second. I then tested at 4K, but because of limitations of what I could output from the computer at 4K, I was only able to do this at 30 frames per second. So if we go and we look at the 30 frames per second at 4K result, and actually I had to do this very slightly differently to make this work. If we look at what you're seeing in this frame here, I've got my laptop on the left, and that's going through the Blackmagic Ultra Studio. The monitor's on the right, and if we look at this particular frame here, we can see, let's maybe just find another frame where it might be a bit clearer. So let's try here. We've got on the laptop 06. If you look at on the table, on the desk, there is an iPhone, and the number on there is 104. There's a 2 frame difference between the laptop and the iPhone. So what that 2 frame difference is, actually, that is the output or the delay in the Blackmagic Ultra Studio. There is a 1.5 frame delay through there anyway that I'm aware of. So the 104 on the iPad, on the iPhone screen there, is the input to the transmitter. I've got the iPhone connected to the transmitter. I'll show you how you do that in a minute. Then on the larger monitor, you'll see that we've got 02. 0203. So we're seeing roughly a 1 frame delay. Let's see if let's go forward another frame here. If we go here, you can see we've got 106 on the iPhone, which is the input to the transmitter, and then on the monitor we've got, or 806 rather, we've got 805/806, and that's suggesting a delay that is 1 frame or a little bit under 1 frame, and that's really good performance. So shooting at lower frame rates, at 30 frames per second, 24 frames per second, you're looking at a delay that's probably sub 1 frame. And that's really actually great. And the other thing here is I'm outputting in using the HDMI. If I show you the frame again, you'll see there's an HDMI cable plugged into the bottom of the receiver. So my output to the monitor is actually at over HDMI, because this was at 4K. And there's going to be some latency in the HDMI. There always is. So this only having this 1 frame-ish delay, outputting over HDMI to the monitor, is a really good result in terms of latency, and I think you'll struggle to get better than that with an awful lot of devices. So for a focus puller, this is going to be a really nice device, because you can monitor in 4K, so you're going to have higher resolution, your image can be sharper if you've got a 4K monitor. So that means that you're going to see your focus more precisely, and you've also got extremely low latency, so it will mean that, you know, finding that optimum focus point, turning the focus wheel and seeing the focus motors respond will be much more precise. So a really nice device for that. Now, in that setup, you saw that I was plugged into an iPhone. So what I'm going to do, show you how that works. So I've got my transmitter here, and I've got the cable that comes with it, and this is an old iPad, so I'm going to go from USB-C, and I'm going to plug that into the USB-C out on the transmitter, and I'm going to go to my iPad 6. This is quite an old iPad. Oh, come on, let me in. So it is rather an old iPad, but the iPad 6 will work perfectly adequately for this. So I'm going to plug my cable in there. And one of the things you'll see actually is it's actually charging the device. So it will charge the iPad or the iPhone, and then we have a direct connection to the transmitter, and you have a really low latency output. Now I'm just going to go to a different clip for a minute. So this is again coming off my Decklink, my Ultra Studio. And I'm actually outputting log from the Ultra Studio, but I've got a LUT turned on here. I can turn that LUT off. You can load your own LUTs into this. There are default LUTs. And then you have all the usual tools you'd expect in any professional monitor. So I have Waveform. I have false color. If I want false color, I can add all different markers to it. I can view single colors. There's also histogram. I can have histogram and waveform. And all the things that you'd normally expect. I was getting my head in the way, sorry. You can have histogram, waveform, false color, all the tools that you would normally expect, zebras, LUT on and off, from any other professional monitor, and it's almost zero latency. You might have come across another device from Accsoon you might have heard of, so it's the Accsoon Seemo. And the Seemo is a low-cost device. The Seemo Pro has SDI and HDMI in, and again converts the phone to a monitor. And this has the Seemo built in, the same technology built into the transmitter. So on your camera, you could use your phone or an iPad as that monitor, and it worked from an iPad 6 up. And the iPad that I have here, this iPad here, I actually purchased this for about £75, and I'm sure you'd be able to pick them up for about $80, and it's a really nice monitor. Now, of course, the other way you could use an iPad, an iPhone, or an Android device is to connect wirelessly to the receiver, or to the transmitter, because you can have multiple receivers and iOS devices and Android devices connected at the same time. And this then opens up the possibility of using an iPad or an Android tablet or a phone as a director's monitor. And if you do that, you don't have to have a separate receiver for the monitor. You can just use the tablet, and you know, an iPad battery now will last many hours, 4 or 5 hours, and they recharge really quickly as well. And the beauty of that is that your director can record locally on the iPad or iPhone, Android tablet, so that they can play back what you've just shot while you're perhaps prepping the next scene or the next shot without disturbing you. They don't have to rely on you playing back from the camera. And it's a really nice way to work in those situations, using that as a director's monitor, and it's low cost. I mean, you know, $75, $80, £80 iPad as a director's monitor connected to transmitter is a really easy, simple way to do things, and the director can wander around. And similarly, you could wander around with the iPad if you're adjusting lights and things like that. So I really like these devices from Accsoon. They're really well made. In terms of power, you also have a DC input on them, so as well as the battery goes on the back. If you want to, you can have a DC input, and this goes from 7.4 all the way up to 16.8 volts, so a very wide voltage range, so no problem running it off a V-Lock battery and things like that. And basically they kind of just do what it says on the tin: 4K up to 60 frames per second transmitter and receiver, HD as well, of course. You can prioritize HD and 4K within them depending on what you need. Robust, reliable, well made. I really like them. Thank you for watching.